Consider the linear system x prime equals to ax of two differential equations where a is a real coefficient matrix. What is the general solution of the system if it is known that lambda 1 is equal to 1 plus 2I is an eigenvector, and lambda 1 vector, so the eigenvector, so I think they meant to say this is an eigenvalue, and this is the corresponding eigenvector. And, well, if you remember the theorem, I think it was chapter 10.2, the theorem says that one of the solutions for a complex eigenvalue is going to be e to the real part multiplied by one of the real part of the eigenvectors times the cosine of the imaginary part times t. Remember, the imaginary part is taken without the sign. And then here we have minus b2, which is the imaginary part, times the sine of beta t. And then the other solution is e to the alpha, which is the real part, plus b2 cosine, not plus, times b2 cosine of beta times t, plus beta 1, which is the real part, times the sine of beta t. So if you remember this vector is the same thing as 1, 0 plus 0, 1, where this is b2, the imaginary part coefficient, and this is b1, the real part. So if I want to write a general solution, it's going to be a linear combination of these two solutions. So I can say, and let me start over here, C1 multiplied by what? By the real part, B1, which is 1, 0, times the cosine of beta times t. Well, what is beta? That is the coefficient of the I, which is 2, minus the imaginary part is going to be 0, 1, because we're only taking the coefficient in front of the I, not the I itself, times the sine of 2t. And then here, we're going to have plus C2. And I always forget this, but don't forget this in real life. I always forget this. So first of all, this has a t in there. And here, I need to write e to the 1t. So it's going to be e to the t. And here, it's going to be e to the t as well. We also have our constant here. And here, we have 0, 1 times the cosine of 2t plus 1, 0 times the sine of 2t. And so which one looks like this? Well, we have C1 e to the t. And we're supposed to have two solutions. So this one's not going to be it. Now, we're supposed to have two solutions with 4 vectors. So this one's not going to be it either. What about this one? This one has 1, 0. This one has a plus here and 0, 1. We want a minus. So this one's not going to be it. And this one is going to be the right solution. All right. I'm sorry for this little mistake here. Don't do it in the test. Make sure you have e to the alpha t. And make sure you add your constants here. And you don't get mixed up which b1 and b2 are. I'll see you next time.